So now that you know one way to stop a Java thread using a volatile flag, which is lightweight but somewhat unsatisfying because it doesn't work with blocking operations, let's talk about how to stop a Java thread using an interrupt request. And we'll see that this approach allows us to have one thread stop another thread or cancel another thread by calling the other thread's interrupt method. So this is a way of explicitly allowing one thread to interrupt or cancel another method. What it does under the hood is, again, it doesn't stop the thread, it doesn't kill it dead or terminate it right away. Instead, it posts an interrupt request from the calling thread to the thread that's being asked to shut itself down. And so this is basically, ultimately, it's like a flag. Interrupts are implemented internally by internal interrupt status flags. So it's kind of like, if you watch a football game, when someone's offsides or there's holding or whatever, the ref throws the flag, and that's an indication that says stop playing, right? I guess in theory the players could ignore that and keep playing, but that wouldn't be, I don't even know what would happen if you were to do that. I guess they would fine you for unsportsmanlike conduct or something like that. So the point is that a flag is thrown, and the way that this happens is that if you call the thread.interrupt method, that sets this flag, and we'll see there's a couple of different methods, but you can set the flag. Likewise, programs can check this flag using one of two different accessor methods defined in the Javathread class. And so one of them is called interrupted, which is a static method, and the other one is called isInterrupted. And as we'll see, each of these methods has a slightly different effect on the interrupt status, as we'll talk about here in a second. These method names are a little bit hard to keep track of because they're almost identical. So we'll take a look at this in more detail. So here's a very simple program that we'll talk about that illustrates how this stuff works. So we're going to use this to start, we're going to use this to start the thread, run the thread, and interrupt a background thread. So here's the main program, the main thread creates another thread. So thread T1 is created in the main thread. Then the main thread starts this thread. It then goes ahead and runs for a while, doing other stuff. At that point, while it's doing its other stuff, the other thread is now up and running. And so you can see after it starts, it runs this little lambda expression. And you can see what this lambda expression does is it loops through all the arguments that are passed in, and it does some blocking arguments, and it does some non-blocking arguments. Some blocking processing and some non-blocking processing. That's what it does. And then at some point, ... down the road, the main thread says, okay, you've done your thing, time out, your time's up, I'm going to interrupt you. So it goes ahead and it sends an interrupt request to thread T1, which of course sets that thread's interrupt status flag. So what happens here is that these methods need to check periodically to see if the threads have been stopped. And we're going to take a look at them, and we'll take a look at process blocking first, and then we'll take a look at process non-blocking. So here's process blocking, and all this is doing is it's just illustrating that this method happens to be calling other methods that can block. So as you can see here, this thread, this method will basically sleep for some amount of time. It might wait for some amount of time, and sleep and wait are two methods, as you may recall, that cause the thread to block because they're going to make you stop and suspend yourselves. Now, the interesting part here is what happens if we're blocking in sleep or wait and the main thread interrupts us. Well, the way that Java works is the way the Java class libraries work is these blocking methods like sleep and wait and join and all these other things, they are designed so that if someone sets the interrupt flag, that will cause those methods to stop waiting and throw an exception. And what they end up throwing is the interrupted exception. So if this thread gets stopped while it's blocked, or gets interrupted while it's blocked, the interrupted exception will get called back, and then you can do something in response to that. And all of these things, wait, join, sleep, blocking I/O calls on interruptible channels, those are all things that the system knows how to unblock you about. So There's another way of doing things too. These are for non-blocking calls. So these are blocking calls, right? So stuff like sleep and wait are blocking calls. Non-blocking, let's say we just have some long-running computation that never blocks. You can also check to see if you've been shut down by calling thread.interrupted. And that's a static method that returns true if the calling thread has its interrupt status flag set. So as you can see here, some long-running operation. If we've been interrupted, we discover that, and then we throw an interrupted exception or something. Non-blocking operations have to periodically check to see if thread.interrupt has been called. There's another method called thread.interrupted has another side effect, which is it clears the interrupt status. So if it's interrupted, it realizes that, and then it says, okay, and now I've handled the interrupt. So that's what thread.interrupted does. There's also another method called isInterrupted. And this is a non-static method, so you actually have to call this on a particular thread. So in this case, we could figure out we are the current thread, and then we could say if my thread is interrupted, this will return true if the interrupted status has been set, but it doesn't change the interrupt status. So it keeps it as interrupted, as it's been interrupted. So as a result, you can call isInterrupted multiple times without actually affecting the interrupt status. Whereas with thread.interrupted, once you call it and it returns true, it clears the status. I don't know about you, but that is very subtle. And so it's easy to get confused. Some other interesting things, just for completeness, you can actually override interrupt and isInterrupted. These are methods that are defined and implemented inside of thread, but because they're not defined as final, you can override them and do other kinds of things with them. And this is an example I wrote at one point for a project not unlike what you guys are doing with the Palantiri simulator, where for various reasons I wanted to redefine interrupt and isInterrupted. Make sure you know what you're doing. If you start overriding these methods, it could cause chaos and insanity, so be very careful with it. But it is possible to do so, so I just wanted to point that out. Okay, so that's the overview of using the interrupt request mechanisms built into Java as a way to cause a thread to voluntarily shut